Okay, so now we're going to start looking at compound interest. So compound interest is a little different. The formula looks a little bigger and has a little more components to it, but really, once again, we'll write it up, we'll break down what each one stands for, and as long as you identify the different variables, you'll be able to use it just like the simple interest formula. Just has a few more in it. So compound interest, unlike simple interest, that when it compounds, so if it compounds yearly, compounds quarterly, compounds, half yearly, every time it compounds, that means it actually pays out that interest, or expects or adds that interest to the amount that has been borrowed, and that becomes the new principal each time. So it makes a big difference, in the, particularly over a long period of time. It's why home loans end up costing so much. But it also means that you can, an investment you can make a lot more of normally. So the compound interest formula is like this. So we start with A because it actually gives us the final amount. Our principal plus 1. Oh, sorry. I forgot my brackets. Bracket 1 plus, and then in a fraction here, we're going to put the rate 100 times n, and it's going to the power of n times t. Okay, so this is what all of these things stand for. This is the total amount. This will be the total amount owed or the total amount earned. That is the principal and the interest. You can see the principal is in there. We work out the interest, it puts it all together and gives a total amount. So that's a little different to the simple interest formula where you're only working at interest. Okay, this one works out a total amount. This is just like in the simple interest formula is the principal. Again, R stands for rate as a percentage. T still stands for time in years only. And then we have this N. So the N is here and here. It's in 2 spots. N is the number of compounding periods in a year. So if it compounds quarterly, that means 4 times a year. So N would be 4. If it compounds half a year, every half year, every 6 months, then it would be 2 compounds. There's 2 halves in a year. If it compounds annually, then once a year. N. Now that we have that, let's do our example over to the side here. So, Susie has $10,000 that she won in Lotto. Lucky Susie. And she decides to invest it in an account, like a term deposit, that pays 8% per annum. It compounds yearly. So we want to know how much she'll have after 3 years. So let's just identify. We've got a principal of $10,000, always our first step. We've got a rate of 8%. I could just write 8, sorry. And then we've got our time, which will be 3 years. And then we need N. So N is number of compounding periods in a year. So if it compounds yearly, once a year, so our N is going to be 1. Okay, so we're trying to find our total amount. So we just write our formula, total amount. Principal, 1 plus the rate over 100 times N, and that's to the power of N times T. Now all I've done is left out the multiplications because it's algebra. We can do that. Now I'm just going to sub in. I don't know the total amount. I'm trying to find it, so that can stay. Principal is 10,000. 1 plus, it's a number, so we don't have to sub in. The rate is 8, and that's going to be over 100 times N. 100 times 1. And that's going to be the power of 1 times, and T is 3. Okay, so once we've done that, let's nut this down a little. So I can just leave my 10,000, my 1 plus, But 8 over, this could just be 8 over 100. Yeah, because 100 times 1 is 100. And it could be to the power of 3. 1 times 3 is 3. So if I bring that down nice and easy, then I can do this calculation here, because BIMDAS will tell us, let's do brackets first, then indices. BIMDAS, brackets, indices. So we'll do brackets first. And of course we want to do the division part first and then add 1, okay? So if we go 8 over 100, so it's going to be 0.008, or 0.08. But basically, and then we add 1 on, we end up with an improper, a fraction, okay, an improper fraction. So that's going to be 27 over 25. Now you can just do that straight into your calculator, okay? And if you've got the TI and SPI, you can use the fraction button. You can do that in most of them and pop that in. Otherwise, you can go 8 divided by 100 equals, and then plus 1 equals, and that will give you this. There should be a button that has like arrows like this, or like an S D kind of button, and that will allow you to go back and forth. Some of them are a little different, but you should be able to find one of them if it comes up as a great big decimal number, because you don't want to do that. Eventually you might be able to actually do most of this in one step. Okay, so then what you want to do is you want to put this fraction to the power of 3. So 27 over 25 to the power of 3, or 27 divided by 25 equals, and then put that answer to the power of 3. But it is much better to actually use your fraction button so that you can get a more exact answer. Then we just multiply by 10,000. So we work this one out here, 27 divided by 25 to the power of 3, and that answer multiplied by 10,000. And what we end up with is $12,597.12. Okay, so after 3 years, Susie will have $12,597.12. It's a nice little addition to her $10,000 win. Okay, so the next one, I just want to do a quick one around sort of future value, just because it's got like 2 steps. So I'm not going to write the whole question out because it'll take so long. So make sure you're listening carefully and maybe actually writing it when you write your example. Actually write out what I'm saying here. So Sam is investing. So Sam, this is our example 2. Sam is investing $6,000 at 8% per annum for, whoa, that's the worst, for 2 years, compounding quarterly. Okay, so that's 4 times a year. What we want to know is the future value, which really is just how much is he going to have after 3 years. That's a future value. Same deal. So you need to get used to the terminology. So we want to know the future value, and we want to know how much interest. Okay, so that's an extra step there. So future value is just what we're going to use in place of something because the investment hasn't actually occurred. We're projecting what it's going to be worth in the future. And really, that's just the total amount at the end. So I'm going to start with just our normal one, but we can actually use FV for future value, but we can still use the same formula. So instead of total amount, we can use future value just to match the terminology. 1 plus 100 over N T. Now we just sub in, so we just choose what we've got. So I've got, this is my principal, this is my rate, my time, and my N is going to equal 4, yeah, because it's quarterly. So it's going to happen 4 times a year. So principal, 6,000. 1 plus my rate of 8, 100 times 4, and it's going to be 4 times 2 for 2 years. So then I go through all that. So 4 2s are 8, 100 times 4 is 400, so I can just go 8 divided by 400 plus 1, and then put that to the power of 8, and then once I've done that, multiply that by 6,000. So if I just step it all out again, I can calculate it through. And what I end up with is 7,029, and then 9, 5, 6, 2, 8, 6, and it keeps going. So what I do is I need to round. So 7,029, and that 956 just means 95. The 6 tells me round up, so 96. Okay, so therefore, future value is $7,029.96. Now, of course, I would actually write in about Sam and the future value of his investment when I did that properly. The second part is it asks how much interest. So my interest is going to equal the future value, because remember, it's a total amount. So my future value minus the principal that was invested. So remember, when you get that principal back, when you get that total amount, that future value, part of that money is your original investment. So the idea is that you actually make money, that you don't lose any of your principal, you just add to it. So to find the interest that you've added, not a loss, an interest, we just take the principal from that future value. So if we've got 7,029 and 96, and we take our original principal over here of 6,000, and we end up with 1,029 and 96 cents. Therefore, this pen is super squeaky, I'm sorry. Make sure we've got dollar signs, $1,029.96. Okay. So basically remembering all the way through, we've got our K1 for our rule, K2 to sub. This one is our calculating, because we've shown that we actually calculated and it gave us a really long decimal number. This here is our rounding, our C1. We've got our M3 informed statement down here, and then the same here, our K1, K2, K3 where we've calculated, M3 our informed statement. This one though, I would probably say, at the end of the 2-year term, Sam would have earned, or it's predicted that Sam would earn $1,029.96 in interest. So you would again take that question information and use that to help formulate your informed statement. Okay, so that is compound interest. So you need to make sure that you practice, that you understand how to use the formula, because our next step is looking at finding, like what we did in simple interest. So here we're just finding the total amount, where this is the unknown. What we want to look at is, what do we do if we need to find the principal or the rate or time? So we can basically do any of those things, doing that same steps that we did in simple interest, just with a slightly more complicated formula. So that will be our next video. Make sure you've practiced your finding compound interest.